Okay, this looks like lower and upper bounds. So we're told that it's 4.72 corrected 2 decimal places. What's the smallest it could be? 4.715. That will round up to 4.72 to 2 decimal places. And the largest it can be, well, it can't actually equal this, but the upper bound will be 4.725. Anything less than that, it can actually equal. So we say it's the upper bound, but we put this inequality sign in. Okay, we've got a similar, a slightly tougher version of this question now. So we're trying to work out, we've got a distance, correct the nearest 10 kilometers, speed, correct the nearest to 1 decimal place, calculate the shortest possible time for Jamal's journey. So speed is distance over time. That means that time is distance over speed. Now we're trying to find the shortest possible time. So we want to make the distance as small as possible and use the lower bound. And we want to make the speed as large as possible. So we're going to use the upper bound. The lower bound of the distance is going to be 425. And then the speed to maximize it is going to be 57.35. I've used similar sort of methods for part A. Hopefully that makes sense. I've not written down the lower and upper bound of both. You could do that. I've just explained why I'm using the lower bound for the distance and the upper bound for the speed. So 425 divided by 57.35, 7.4106. However, this is in hours, and it says give your answer correct to the nearest minute. It's going to be 7 hours, and then I need to change 0.4106 hours into minutes. And I can do that by timesing by 60. It's not 41 minutes. This is like, we need to change basically to a sort of base 60 is what we're actually changing to. So we're timesing by 60, 24.638. And to the nearest minute is going to be 25 minutes.